Bismillahirrahmanirrahim. Friends, today's our topic is glycolysis. Well, glycolysis it's a simple and the easiest process in the respiration. Well, we are starting with the definition of glycolysis. The word glyco means glucose and glucose means sweet in taste and lysis means to split out or the break down something. Glycolysis is the breakdown of glucose up to the formation of pyruvic acid. Now, a glucose molecule is break down into 2 pyruvic acid. Remember one thing, glucose is a hexose. It contains 6 carbon, whereas pyruvic acid is a 3 carbon compound. So, this is a basic concept that large complex molecule like glucose is converted into simpler one like pyruvic acid. The reactions or the pathways is catalyzed by different enzymes. It may be kinases, phosphatases, etc. Well, glycolysis has completed just in 2 phases. The first one we called it preparatory phase and in another one we called it oxidative phase. Now the preparatory phase is further divided into this one like 1 to 4 steps in glycolysis. In this process, a glucose molecule is just added by a phosphate group, like phosphorylation of glucose takes place. Whereas the next one we called it oxidative phase. It contains about 5 to 9 steps in glycolysis. And it is called as oxidative phase because in this way the highly phosphate energy or phosphate bonds are formed and energy is stored. Okay, this is the general pathway of glycolysis. First of all, we have just glucose molecule. It is a respiratory substrate. Like glucose is a 6 carbon compound and containing a functional group, we call it aldehyde. So sometimes we call it glucose as a aldose sugar. The first step, which is an important step, we called it phosphorylation of glucose. In the first step, a glucose molecule is related with an enzyme, we called it hexokinase, and in this way an ATP molecule is converted into ADP molecule. ATP contains a highly rich phosphate group like ATP, adenosine triphosphate. One phosphate group is added to glucose molecule which is turned into the glucose 6-phosphate. Now what is the meaning of glucose 6-phosphate? It does mean that a glucose contains phosphate group at carbon number 6, so that just simply a phosphorylized. In the first step, just we say a glucose is phosphorylized into a glucose 6-phosphate. Okay, now step 2, which is called as isomerization. This isomerization is the conversion of just functional group like glucose is converted into fructose. Glucose 6-phosphate is isomerized into fructose 6-phosphate, as we know that glucose and fructose are the isomers to each other, so that we just called it glucose is converted into glucose 6-phosphate, which is in a with the enzyme we use like phosphoglucoisomerase, which turn the glucose 6-phosphate into fructose 6-phosphate. The next one we called it second phosphorylation. Okay, remember one thing, there are 2 phosphorylations takes place inside the glycolysis. In the first step, like glucose converted to glucose 6-phosphate. The second phosphorylation, that is fructose 6-phosphate, is converted into fructose 1,6-diphosphate, or sometimes we call it bisphosphate. So another molecule of ATP is used and the conversion of fructose 6-phosphate into fructose 1,6-bisphosphate takes place. Now the cleavage, step 4, cleavage. The enzyme here we use like fructose 6-phosphate is converted into glucose 1,6-bisphosphate, and the enzyme is phosphofructokinase. Step 4, that is a cleavage. Cleavage, it means that fructose 1,6-diphosphate or bisphosphate is converted into two different molecules like dihydroxyacetone phosphate. Shortly we called it DHAP, whereas another one we called it phosphoglyceraldehyde. Now remember, dihydroxyacetone phosphate and phosphoglyceraldehyde, they are isomer to each other, they are interconvertible. So the cleavage takes place by an enzyme we call it aldolase. Dihydroxyacetone is converted into phosphoglyceraldehyde. Here we have two molecules of phosphoglyceraldehyde. This step. Now phosphoglyceraldehyde is further. This phase is also called as oxidative dehydrogenase. Like in the process of enzyme we call it phosphotriose dehydrogenase. In this process, phosphoglyceraldehyde is converted into 1,3-di we called it diphosphoglyceraldehyde or glycolic acid. An enzyme we called it NAD is converted into NADH2. Like 2 hydrogen is released from the phosphoglyceraldehyde, along with an inorganic phosphate is added into the reactions. That's why phosphoglyceraldehyde PGAL is converted into 1,3-diphosphoglyceric acid. Next step, that is the ATP generation. Now 1,3-diphosphoglyceric acid has a rich phosphate group, so that it is treated with the ADP molecule. 2 molecule of ADP is used to form the 2 ATP. As we know that we are just using here 1,3-diphosphoglyceric acid are the 2 molecules, because at the previous one we just discussed that there are 2 groups of dihydroxyacetone is further converted into the phosphoglyceric acid or phosphoglyceraldehyde. So we are just taking at the 2 molecule. Hence we just use a 2 molecule of ADP, which will convert into the ATP molecule. Like 2 ATP are formed here. Now the next step called it the enzyme, the reaction is catalyzed by enzyme we called it phosphoglyceric kinase or phosphoglyceraldehyde kinase. As I just remember that where the phosphorylation takes place or dephosphorylation takes place, an enzyme we called it kinase is used. Kinesed. The next time we called it the next step number 7, we called it isomerization. The isomerization in which the 3-phosphoglyceric acid is converted into the 2-phosphoglyceric acid. What does it mean 3-phosphoglyceric acid is converted into 2-phosphoglyceric acid? It just the position of phosphate, it just the change in the position of phosphate group into the 2 position. Here at the carbon number 3, a phosphate group is attached, whereas with the presence of enzyme we called it mutase or phosphoglyceromutase. This enzyme just changed the position of phosphate group from 3 carbon to 2 carbon or 2 position in the phosphoglyceric acid compound. The next step we called is dehydrogenation. In this way the water is released, dehydration takes place, not a dehydrogenation, it's a dehydration, just simply the removal of water. The reaction is catalyzed by enzyme we called it enolase. By removing the water, just 2-phosphoglyceric acid is converted into phosphoenol pyruvate, which is commonly called as PEP. The next step we called it phosphoenol pyruvate is further converted into the next pyruvic acid, and the ATPs are generation. The enzyme is used like a pyruvate kinase, and the two molecules of ADP are used, which is result into the ATP molecule, or ATPs are formed. Hence the product is the two molecules of pyruvic acid right over here. Now the pyruvic acid is the last, or we can say that the product of glycolysis. Well, the product of glycolysis is the two molecule of pyruvic acid, which is a 3-carbon compound. There are 4 ATPs are formed here. 4 ATPs are formed, whereas the ATPs which are used, like we just use in the phosphorylation, there are 2 in number. So 4 ATPs are formed and 2 ATPs are used. Hence the net ATP will be the 4 minus 2 is equal to 2 ATPs.